So, here's Archimedes' law of buoyancy. So the things you're going to need to demonstrate this are going to be a scale that you can zero out once you put a cup on top of it that will hold at least the size of your object that you're going to be putting in the water, that will hold the same amount of area or volume as that. So the first thing that you're going to want to do is get all your supplies. You'll need two bowls, a big bowl, like big, and then a little bowl that's inside of that you can put water in all the way to the top so it's barely leaking over, and then your object to put in it. And so what the law is the volume of this object is going to go into the water, and it's going to push water out of the bowl because it's displacing it, and then you're going to measure the amount of water that it displaced. And the idea is that the amount of water that it displaces in like weight, not volume, is going to equal the same amount of upward force against this object in the water, or the buoyancy of it. And so this is going to weigh that much lighter in water if you were to have a scale underwater. So first thing we're going to do when demonstrating this is we're going to, obviously there's no water in the outside bowl, it's only in the inside one. So you're going to dip this in here all the way, and the can's not completely under because that's just air on the top, so we can have it like that. Then you want to make sure to pull this out carefully so that you're not pushing any more water out. And then you want to take this bowl out without spilling any water. And then you want to measure the water that your object displaced. Which on the scale it's about 12 ounces in not fluid or volume, so 12 ounces. And then you can take that off and zero this back. And this weighs right at about 14 ounces. And so that's the experiment, kind of, I guess. And then that's my poster. There's a little kind of a demonstration. That's a demonstration on what I just did here.